Hello everyone, back again from Hand Tools. I'm Richard Burton, and we're going to be looking at this week, or this time, Measuring Tools, Chapter 11. So last time we covered the metalworking tools, and hopefully if those were something that you had never seen or been familiar with, now you have a little better understanding about those. So today we're hoping to get you a little better understanding about measuring tools. A lot of times when people think about measuring tools, they're probably predominantly thinking about a tape measure and possibly a ruler. But we're going to go a little bit farther than that because, as you know, manufacturing things have to be very precise and things have to be replicated to certain tolerances. So that's what we're kind of going to be looking at here with measuring tools, is how can we use tools to be able to verify those sizes and to make sure that they are replicated and that we stay on tolerance when we're making these parts. So one of the first things that is brought up in the chapter is on 11-04 on page 157. And it talks about that the United States and Canada have historically been a unit of linear measurement, and that linear measurement happens to be the inch unit. So if you go anywhere else in the world, which is most of all the other countries, you're going to see everything in the linear measurement of meter, which would also be millimeters, centimeters, and kilometers, and so on. So we use inch here. Most people are more comfortable with the inch system when we talk about measurements, and because you can't go into a hardware store and not see the inch system and see fractions, we are going to be covering those to a full extent. So once you finish this class, you should know all there is to know about measurements and shop math and anything to do with fractional sizes and anything that relates to the inch, and then also to how to convert the inch to the metric size. Okay, one thing that, like I said, I mentioned before, we talked about, in most cases, you're used to seeing any tape measure that you buy here in any hardware store in America to have the inch system on it. Occasionally, you will find a tape measure that has the inch and the centimeter system on it. Like this particular tape measure here starts out on inch on one side and then starts out on centimeters on the other side. So you don't commonly find these, but when you do, just know that if you were to go to another country to work, you're probably going to need a tape measure like that to be able to measure something, because everything over there is going to be noted in metric. All right, so next we're going to be looking at 11-10, which is on page 158, where it talks about using a ruler to measure something. In most cases, we think about rulers, we think, well, from end to end, we got two edges here. This is a ruler which goes 12 inches, which is a foot. But in some cases, when we want to measure something, we don't typically want to use the very end edge to get an accurate measurement of something that we're trying to pinpoint. Mainly because it's hard to see the very end of this as a lining mark. So what the book says to do, and you'll probably find this to be easier doing this yourself, is you take that to the first graduation mark, which will be like 1 inch, and then line up your edge to the marked edge, and then read that measurement there to the other marked edge, and it makes it a lot more accurate for you to look at that instead of trying to visualize that end edge to the other end of an edge. It gives you two lining marks. So that's one thing that they wanted to make you aware of. The next thing it talks about is just steel tapes in general. If you notice this steel tape here, it's got 35 wrote on it, which means that this steel tape will measure something up to 35 feet. In a lot of cases, 35 feet will cover just about anything around your home, going to a pretty decent distance, but not incredibly long. If you also notice, in 35 feet, this thing becomes pretty heavy and also pretty large. Be hard to carry that around on your in your pocket or hooked to your belt all day because of the weight of it. This particular one here is a 16 foot. You can look at the difference in the size and tell this would probably be a lot more comfortable to carry. And even if you had to measure something longer than 16 foot, you could also use this and just make you a mark somewhere that you know is pre-measured and then measure again from that mark, and you could do that as many times as needed to get the length you want. Also, this particular tape here is not as rigid as that tape, but it's still made out of a steel material, and this will go up to 50 foot. So this is kind of like a roll-out tape. You have to roll it back up, kind of like wind it back up. It doesn't have a spring inside of it, so you don't have all that extra mechanism in there that takes up space. So this is a little more compact, but it will go up to 50 foot. So that prevents you from having to do the 16 foot 3 times or carry something big and bulky like a 35 foot around if you needed to go some extra distance there. On page 160, it talks about just some basic materials that you may need to measure. It shows a picture of some different bolts and how those bolts are measured for length. Another thing it brings out, it talks about pipe being measured. This is actually a steel galvanized nipple, and it is measured in the size 3/4. Now, if you took a measurement of the outside of this diameter, this is not 3/4. Pipe is always measured by the inside diameter. So keep in mind that this pipe could be as thick as it wanted to be. As long as the inside diameter is 3/4, it's going to be considered 3/4 pipe. In a lot of cases, when you hear the word schedule mentioned with pipe, the higher the number of schedule, the greater the thickness of the wall of the pipe. Even though it could be a 3/4 schedule 80 or schedule 40, the schedule means that the thickness of the pipe is going to be greater on the outside. All right, the next thing we're talking about measuring tools, we're going to look at some calipers. And one thing it mentions about calipers is that there's a picture on page 161 on figure 11-8 that talks about a firm joint caliper. And on that firm joint caliper, I don't actually have a set of those to show you in my hand, but on a firm joint caliper, you set the calipers to whatever size you need them, and then you have to lock down basically like a little locking screw to hold them in place. What I have is a pair of calipers that are spring loaded. They have this spring on them, and they're called spring joint. So as I push these in, the spring forces them back open. So if I adjust this adjustment screw out, the spring allows for them to open up and sets the size that it needs to be set on that. This is also considered to be an outside measuring caliper. So if I adjust these down for this pipe here, I want to close them up to the point where I can barely fit them over the pipe, and that will determine the exact thickness of this pipe here. As long as I can fit them over it, that's exactly the thickness it needs to be. So where's the measuring on this? There is none. The only way I can determine the size of what I've just measured is to either take a rule and go back and measure it on the rule, or I could use something like a slide caliper and measure that inside distance there. Even though these are outside, I got to measure it with something that can measure the inside, so I'll know exactly how great or the size of that dimension is, how wide those are opened up. The other thing I would want to do is these are called inside calipers, and they do exactly the opposite. Instead of outside, you fit these to the inside of the diameter. As long as they slide in and out, making contact with the material, I know the exact distance there. If one good thing about the inside is if I loosen this screw up and I get looseness here, that's telling me I'm touching on the inside. I will just slightly close these back till I feel pressure on the screw, and then I know that I've actually got the exact inside measurement caught. And then I could come back again with a ruler and check it, which that's measuring right at 3/4 of an inch, which is a 3/4 pipe. So we know all that's exactly how it's supposed to be. So one thing it does tell you in the book is a warning on page 163, and you're probably familiar with a lot of machines that run parts, and sometimes when machines are running parts, people are tempted to try to do a measurement on a part while the machine is running. Maybe not necessarily while the machine is cutting the part, but while the machine is running, they want to take a quick measurement so they kind of save time. But it says never try to do any measurements while the work is rotating. And I would even go farther than that and say, don't check anything even if the machine is running at all. Shut the machine off, make sure everything's safe and clear, and then get your measuring tool out, check the part, verify your measurement, and then start the machine back up after everything is clear and out of the way. But definitely don't try to measure anything while it's rotating and work is being done to the part. The next thing it talks about is an actual slide caliper called a vernier caliper. And a vernier caliper means that this caliper right here is equipped with a scale called a vernier scale. And on that vernier scale, you have your main scale here that you first have to read. And once you read on this 0 mark here, where the size falls, then between these graduates, there's a secondary scale called the vernier, and you line up those index marks with another index mark on the main scale, and you can determine exactly the size of something up to 1/1000th of an inch. So you're saying, all right, what's 1/1000th of an inch? Give me something I can understand, okay? So 1/1000th of an inch would be, if I measured the thickness of this piece of paper right here, this piece of paper is actually 4/1000th of an inch. So if that tells you how small 1/1000th is, it takes 4 1/1000ths to make the thickness of a piece of paper. So 4/1000ths of an inch is the thickness of a piece of paper in this book right here. All right, so this is a caliper, a slide caliper here with a vernier. Now we're going to look at something called a micrometer caliper. Some of you have heard of micrometers, some of you probably haven't. If you've done any auto tech classes in the past, maybe you've seen someone use a set of micrometers to check the thickness of a brake caliper. You say, well, why would somebody check the thickness of a brake caliper? Well, as you know, brakes contact the caliper on your wheel, and as they run, they wear the caliper down. So it's very important that once those calipers get worn down so far, that instead of being machined and resurfaced, they must be replaced. So a lot of times a mechanic will keep a set of these so they can verify that thickness, because it's usually wrote on the caliper somewhere how the minimum size of that caliper should not be reused if it gets below that. So that's just something that you may be familiar with from that. Another thing to keep in mind here is, if you can see this, it says on there 0 to 1 inch. So what does that mean exactly? That means that this caliper, this micrometer here, can only measure something that is from 0, which is 0 is nothing, to 1 inch is the largest this caliper can actually fit. So anything over 1 inch, this will not measure it. It's too big for it. So after it becomes larger than 1 inch, you go to the next size micrometer. This micrometer here is 1 to 2 inch. So now this micrometer here will do exactly the same thing. Anything larger than 1 inch, it'll actually measure, but anything that's larger than 2 inches, this will not measure it. It's between 1 and 2 inch caliper. So all calipers do that. They go from 0 to 1, 1 to 2, 2 to 3, 3 to 4, and so on and so forth. So that's how the caliper is actually set up to work. These are also considered to be more accurate than these as far as the way they contact the material and touch. These are very slender on the side, so they can easily be skewed a little bit. These are more beefy and flat, and they're harder to skew. They'll give you a more precise fit when you're measuring something. So you can trust these to be more precise sometimes than these, based on misalignment and certain ways that you hold them to take the measurement. There's also a scale that's in the book that it shows you how do you read a micrometer that's not actually digital. A lot of us like the digital stuff. I've got a set of digital calipers right here. When I slide these, they count. We like digital stuff because it's so much easier to use. And I totally agree that they are easier to read in cases, but not always are you going to have the luxury of having a digital micrometer. So it's always a good idea to learn how to read these. So it shows you how the scale works in the book here, and it also lays out the certain parts of this micrometer. So the spindle is the main part of the micrometer. That's the part that moves in and out. And then you also have the anvil, which is the part here that the material rests against. And then you have the sleeve over here where the scale actually measures to. And then on the thimble, which is the part that rotates, which moves the spindle in and out, you can take a reading from there. So you use the sleeve scale to line up with the thimble scale. And you have to take those measurements and actually add those together in order to do that, to get your actual measurement. We will do more with these once we get into lab. So right now I'm giving you the fundamentals of a micrometer, but not necessarily the total how to use the micrometer right now. Okay, so next thing I wanted to bring out is in figure 11-17. There are several different micrometers that are made for industry. One of those being a deep throat micrometer, another one being a screw thread micrometer, another being an outside with rounded anvil micrometer. Then you have very large micrometers that do like extreme sizes. And then you have one called a tube micrometer. So those are 5 different ones to keep in mind that are made for industry to use. Micrometers have a very special purpose, a lot of times for measuring parts. The next thing we're going to look at is something called a square. Most of us probably know square means 90 degrees, right? So on page 167 at the bottom, it talks about a framing square. So a lot of times we may have a reason we need a very large square to be able to verify something is truly squared up. I mean, you may be working on a machine and you're trying to make sure that this point over here and this point way back up here are sitting square to each other. You may need something made this fixed like this that is able to do that. So a framing square has something called it has what they call a body or blade, and then it has a tongue. And the shorter arm is called the tongue here, and the larger is called the blade. The blade is usually 24 inch, which is what this is, and then the the tongue is usually 16 inch. So if we know anything about carpentry, we know that 16 inch is typically what the studs in a wall are on center, and 24 inch is usually what the trusses in the ceiling are on center. So those two particular measurements are very important when it comes to framing structures. And so when you're doing framing of any kind where you're building something out of wood, these come in very handy. There's also a lot of geometry on these things. And this particular one here has an extra option. On the back, it is actually all metric. So if you really want to tackle some extensive building, try to build something in metric and see how well that works out for you. Because trust me, these graduates don't end in perfectly rounded numbers like the ones on the other side of the framing square do. So that's something to keep in mind there. Another thing that you may need when you're working in a shop is just a basic square. So what does a basic square do? All it will do is help show you when something is actually square this way, or if something is sitting square this way. It just gives you that 90 degrees in two different points. And it's got a thick base so it can sit upright, or it will hang over something and lay down and hang over the edge so you can determine if you've got something squared up to an edge or not. Say I wanted to determine if this edge right here was perfectly square. I can lay this against it, bring it up to it, and yep, this edge is perfectly square. There may be times when you need to know that. So the square comes in very handy to be able to do that. Unfortunately for the framing square, it does not have any kind of way to overhang it, so you have to like let the edge fall over, which means that this edge is turned down, so it can get sometimes a little bit harder to hold all this straight if you need something with a hangover edge like that. Which leads me up to the last thing that we're going to look at in this chapter, and that is something called a combination square. So what is a combination square? A lot of times a combination square, it gives you a whole mixed bag of different parts that you would need to use in squaring up any type of setup that you're going to be working with. So for one thing, it comes with a steel rule. So you can use that steel rule without ever even pulling out anything else. From that steel rule, you have your first head, which is called your square head. The square head also has a 45-degree miter on it. It also includes a level, and this particular one still has the original scribe with it. So you can unscrew the scribe from the end, and then you can use this as scribe on metal, and then it neatly goes back into the head and tucks away for safekeeping. So the steel rule works on all three of these heads, and this slides in like so, and now you have something that can be used for a height gauge. You could set it at any depth you want because it's wrote on here. So I want to set that at 4 inches exactly. And then I want to check something to see if every time I lay this here, it's exactly 4 inches from here to here. A height gauge, a depth gauge, however you want to call it, that makes for a lot of wonderful quick tricks, I guess you can say, for measuring. The next thing this has is something called a center head. So you're like, what does a center head do? So this rule will slide into the center head, if it will cooperate for me. Sometimes these things can be a little bit finicky. So now that's up inside there. So this ruler is exactly in the center of this V here. So if I take something round and place it up in that V, I can see exactly where the center of anything circular is with this rule right here. This comes in very handy if you need to lay out something that's round and find the exact center. Because as you know, it's not easy to always pinpoint the center of rounded parts. Sometimes it looks like you're in the center, and then once you fasten something or drill a hole in it, you find out that you were off center, and then it's really too late to do anything. So having something that'll mark it for you is a great tool to have. We're going to pull that out of there. And last thing we have is what most of you probably know as a protractor. This head here also has a level gauge on it and has the ability, if I can get this thing to cooperate. When I say cooperate, I basically mean, can I make it work? Sometimes I can, sometimes I can't. All right, so now I can take this and turn it, lock it in place, and I can set it on any angle I want based on this mark right here, and it tells me the angle of this right here, and I can check and determine almost any angle of anything that I'm wanting to figure out. I got to tighten this up to make that lock down super rigid. But now I can find the angle of anything I want to based on this dial here with this long. And basically all we're using this ruler for on this is just a straight edge. But if I did need to count the distance of something, I can also use that to count the distance as well. So basically, the combination square, it says it can be used on page 169, section 11.66. Can be used as a tri-square, a miter gauge, a height gauge, a depth gauge, a steel rule, a center gauge, and a bevel protractor. All of those tools in one. And probably even more there than I mentioned. They didn't even mention anything about this being good for being a level, but this particular one has a level on it. So I could sit this down on something and even determine the levelness of something that's supposed to be sitting flat. So there's a lot of great uses with a combination square. So I pretty well covered through the chapter. I know I went kind of fast. I just wanted to kind of give you a rundown of those. A lot of times it's not as easy to gather this information reading it. I like to kind of give it to you in this delivery as well, as if we were sitting in a classroom and I was talking and you were sitting there listening. So hopefully you'll take advantage of watching these videos, and everything that I probably just mentioned in here is going to go along with the questions you have to do for review. So make sure that you spend a little bit of time and take full advantage of getting as much information as you can, so when you do your reviews, the information from the reviews are also going to be what's on the test. So we're hoping that this 1-2 punch will help you make an excellent grade for the test. That's all I got for today. See you till next time.